We are Group A1, and the lab that we are presenting is the Visual Classification and Specific Gravity Lab. Here is a quick overview of the content and topics that we will address here. We are going to discuss the objectives for each portion of the lab, the theory behind the lab topic, the procedure followed for gathering the necessary data, some discussion about the results in comparison to similar labs, and what we can conclude from the completion of this lab and the data gathered therein. When discussing the objectives for this lab, it is important to note that there are two main sections, each with their own set of objectives, with the first being visual classification. The objective for the visual classification portion of the lab is to first determine the grain size of each soil as coarse, fine, or mixed, and then determine further characteristics based on that first categorization, with a baseline set of tests being run on each sample. Once all of that data is recorded, each sample can be then classified according to the USCS standard. The second portion, the specific gravity portion, has a very simple objective: to determine the specific gravity of the given soil sample using the heat method given in the ASTM standard.
The theory behind the visual classification lab is important. Fundamentally, soils are all made up of a bunch of small particles, and how these particles are sized, spaced, and interact will have a great impact on the properties of the soil. We can assess these properties through different means to make educated assumptions about how a soil will behave. We can look at the soil, see if it is fine-grained or coarse-grained, see if the particles are rounded or angular, feel its texture, smell its odor. All of these things are good indicators of how a soil will behave. We can also use simple tests to evaluate dry strength, dilatancy, and toughness, which will lead to an even better assessment of what type of soil it is. Once we have identified those things, we can go to the charts provided to us in the code and find the right type of soil that fits our observations. Once we have identified the soil and named it correctly, the code gives us advice on that type of soil's best field uses. After a classification is made, geotechnical engineers can then make design decisions based on the code's recommendations, so it is important to get your visual classifications right. The theory behind specific gravity is rather simple, but nonetheless important. Specific gravity is defined as the ratio of the weight of a given volume of a substance to the weight of that same volume of water. It is useful to geotechnical engineers because it tells us how much heavier or lighter it is than water. So, when a geotechnical engineer needs to know how much soil needs to be brought in for a fill or taken out of a cut, having this number will help to evaluate what tonnage and volume is necessary to move. We can determine the specific gravity of a soil sample through two different methods. One is to use heat, and the other is to use vacuum. In both cases, the aim is to remove all air from the soil sample so that only the water and soil particles remain. This weight of volume is then compared to the same weight of volume of water, and our specific gravity is found.
It is important to have consistent and reliable data, and to ensure this, a standard procedure was followed for each portion of the lab. The following is the procedure for the visual classification portion. First, a sample was chosen, and the sample number recorded prior to any other data or tests being done. Next, the basic characteristics were determined, such as color, odor, and texture, and then dispersion was measured by placing a small portion of the sample into water, shaking, and then recording how long it took for the particles to settle. Next, it was time to decide the grain size of the sample. Was it coarse, fine, or mixed grain? And then further characteristics were recorded based on that grain size. For coarse samples, gradation and particle shape were recorded. For fine samples, dry strength, dilatancy, and toughness were recorded. And for mixed samples, all of those previous characteristics needed to be recorded. Once all of the data was gathered, it is possible to classify each sample according to the USCS flowchart, and then these tests were repeated for each sample. The following is the procedure for the specific gravity portion of the lab. First, the pycnometer was calibrated, and then 25 to 30 grams of oven-dried soil were placed into the pycnometer, which was then filled 1/3 full with distilled water, heated until boiling, and then allowed to boil for 10 minutes. After the 10 minutes, the pycnometer was removed from heat and filled with water to the bottom of the meniscus. At this point, the water/soil in the pycnometer was allowed to cool below 30 degrees Celsius, at which point the mass of the pycnometer soil and water was recorded along with the temperature of the water/soil mixture. At this point, all of the necessary data had been gathered and was used to calculate the specific gravity of the soil sample, which was then compared to given data to determine the accuracy of the lab results.
This slide represents the results of the visual classification portion of the lab. We had 4 different soil samples, and we were tasked with visually classifying them. Following the procedure mentioned before, we were able to classify each soil sample by its color, odor, texture, dispersion quickness, how graded the sample is, and a rough estimate of general particle size. We were also able to create general analyzations of the sample's dry strength, dilatancy, and toughness. You will see parentheses C parentheses and a parentheses F parentheses besides certain classifications in the table shown. These are representative of visual classifications done on coarse-grained and fine-grained soils, respectively. Only coarse-grained soils went through the test with parentheses C parentheses, and only fine-grained soils went through the test with parentheses F parentheses. If a soil was classified as mixed, it went through both coarse and fine-grained soil tests. This slide represents the results from the specific gravity portion of the lab. After following the lab protocols mentioned earlier, we were able to either measure or calculate the values in the table seen. We were also given 2 tables in the specific gravity handout that gave us 1. Specific gravity values by soil type, and 2. Water densities and correction factors for different temperatures. We used the second table from the handout to find the initial and final temperature densities and the temperature coefficient K. We also used shown equations to calculate the mass of pycnometer plus water at final time and the specific gravity at 20 degrees Celsius. Our discussion is broken down into 2 different segments: accuracy of results and statistical analysis. Each of these were related to the visual classification and specific gravity portions of the lab. For the visual classification discussion, we compared our data to the example data and results provided in engineering properties of soils based on laboratory testing done by Professor Krishna Reddy of UIC. It seems that our results and classifications were fairly accurate. In this journal, they examined 2 coarse-grained soils and 1 fine-grained soil. Our group identified 2 mixed-grain and 2 fine-grained soils. This could be a sign that we were too picky about our classification of coarse versus mixed-grain soils. In short, we could have identified a coarse-grained soil as a mixed grain, but that is a difficult classification to make as we cannot tell exact ratios just by eyesight. They also analyzed a fine sand while we classified 2 fine clays, which should have different dilatancies and dry strengths, which is shown by our differing answers, so that seems to be correct. For the specific gravity discussion, we compared our data to the trends found in the results in an Army lab that matched loosely to what we saw in our experiment. They started with a total of 692.05 grams, which included the flask plus soil plus water, and ended up with 655.75 grams at 29 degrees Celsius. In our experiment, we started with 684.85 grams and ended up with 668.12 grams. However, they do not describe how exactly they reached this specific number. They explain that they are using a graph that projects values based on past data points. So considering all the possible errors we could have encountered, it seems we were on the right track, but maybe messed up some things along the way, as we did not see as steep of a decrease in mass as the lab done by the Army did. For the statistical analysis portion of our discussion, the visual classification part of the lab does not have one. For the specific gravity part of the lab, we use the values from our data as well as the values from the other groups in our lab section to find the mean, standard deviation, and coefficient of variation for the 5 measurements seen in the table. These measurements were the mass of the pycnometer plus water final, density of water at initial temperature, density of water at final temperature, temperature coefficient K, and specific gravity at 20 degrees Celsius. Our data was very similar to the data given from the other groups, showing that the accuracy of our data can be assumed to be correct. To wrap our presentation up, we wanted to say a few concluding statements. This lab was supposed to teach us how to visually classify soils based on color, odor, texture, dry strength, dilatancy, toughness, gradation, and particle size. We also learned the process of determining the specific gravity of a soil sample using the heat method outlined in the lab procedures. The specific gravity can then be used to classify the soil sample given previously experimentally determined values for different soil types. This lab was also supposed to give us an introduction to how soils labs are done and how to properly follow laboratory protocols and techniques. Following these protocols and techniques allowed us to have fairly accurate results when compared to the other groups in this lab section, as well as comparing them to the mentioned lab reports done by the external groups.